Hello everyone. Today I'll be discussing a critical challenge in mass spectrometry chromatography. That is, identifying and tackling false negative and false positive peaks in LC-MS-MS and GC-MS-MS analysis. False peak can lead to serious consequences. That is, misdetections of target compound, false identifications, incorrect quantification, and ultimately flawed analytical conclusion. Whether you're working in pharmaceutical analysis, environmental testing, or food safety, understanding how to recognize and address these issues is essential for data integrity. So let's dive into what causes these false peaks and, more importantly, how we can prevent and resolve them. So let's start with understanding what are false negative peaks. So false negative occur when an analyte is present in your sample but fails to produce a detectable peak. Essentially, you're getting a not detected result when the compound is actually there. A scenario that can have serious regulatory and safety implications. So let's see what are the common causes in LC-MS-MS and GC-MS-MS to get a false negative peak. So first is there can be ion suppression or enhancement. So ion suppression or enhancement is perhaps the most notorious culprit in LC-MS-MS. When co-eluting matrix components interfere with the ionization process, your target analyte may not ionize efficiently, leading to reduced or absent signal. This is particularly problematic in electrospray ionization. Second, coming to matrix effects. Now, matrix effects can completely mask your analyte. High salt biological matrices, lipids, or proteins can cause significant signal suppression. In GC-MS-MS, non-volatile matrix components can contaminate the injection port or column. Third cause be poor chromatographic resolution. It means your analyte might be hidden under a large matrix peak. If co-elution occurs with abundant matrix component, your signal can be completely obscured. Fourth is inadequate sample preparation. If your extraction efficiency is poor or if your analyte degrades during preparation, you won't see it in your analysis even though it was present in the original sample. The last one can be instrument sensitivity. Now this includes detector saturation, contaminated ion sources, or degraded column performance can all lead to false negative peak. Now we have learned the causes. Now let's learn how to identify the false negative. So first one is using matrix matched calibration standard. Use matrix matched calibration standard to verify that your method is actually capable of detecting the analyte in real world matrices, not just in clean solvent. Second is perform recovery studies with fortified samples at relevant concentrations. Third is monitoring the internal standard closely. If they show suppression, your analyte likely do too. Conduct post-column infusion experiment for LC-MS-MS to map exactly where ion suppression occurs in your chromatogram. Now we've understood what can be false negative and how to identify and tackle them. Now let's see what is false positive peak. Now false positives are signals that appear to indicate the presence of your target analyte when it's actually not there, or when the signal comes from something else entirely. This leads to reporting compounds that do not exist in your sample. Now this situation is equally problematic for regulatory compliance and scientific accuracy. So let's see what are the common causes over here. So there are 5 common causes. First is isobaric interferences. Now this occurs when compounds with the same or very similar mass to charge ratios coalesce with your expected retention time. Even with MS, insufficient fragmentation selectivity can cause misidentification. Second is the most common, that is contamination sources. Carryover from previous high concentration sample or column bleeding in GCMS, contaminated reagents or solvent, and even laboratory air contaminants can all create spurious peak. Third is background noise and chemical noise. Now, background noise and chemical noise from the matrix can be misinterpreted as analyte peak, especially near the limit of detection. Polymeric interferences from plasticizers or pump seal materials are common offenders. Fourth one is incorrect peak integration. Now this happens when the software algorithms pick baseline noise, shoulders of adjacent peak, or artifacts as your target peak. The last one is adduct formation or in-source fragmentation. Now an MS can create unexpected signal that might be mistaken for your analyte, particularly if you're not monitoring the right transitions. So how to identify false positive? Retention time. Verify retention time consistency against your authentic standard within plus minus 2 tolerance. If the retention time doesn't match, it's not your compound. Second one is checking your ion ratio. Check ion ratio criteria in MSMS. The ratio of qualifier to quantifier transition must match within the acceptable limit, that is typically plus minus 20 to 30%. Third one is review the full spectrum to confirm molecular, ion and characteristic fragments. Fourth one, run blank samples frequently, including solvent blanks, matrix blank, and method blanks to identify contamination pattern. The last one is performing dilution test. True analyte signals should decrease proportionally while matrix interference often don't. So by following these steps, you can identify the false positives. So let's learn about the practical solution and prevention of these false positive and false negatives. So coming to optimization strategies. So for chromatography, improve suppression by optimizing your mobile phase composition or temperature gradient. Extend gradient times if necessary to separate critical pairs. In GCMS, select columns with appropriate polarity and film thickness. Consider two-dimensional chromatography for complex matrices. Second is for mass spectrometry. Optimize your MSMS transition by evaluating multiple fragment ions and selecting the most specific. Adjust collision energies for maximum specificity versus sensitivity. Use high-resolution mass spectrometry when available. It dramatically reduces false positives. Employ polarity switching carefully and optimize source parameters for each analyte. Third is sample preparation improvement. Implement more selective extraction procedures like solid phase extraction with appropriate sorbent chemistry. Use cleanup steps such as dispersive SPE to remove problematic matrix components. Consider immunoaffinity purification for highly specific isolation. Dilute samples strategically. Sometimes simple dilution reduces matrix effects significantly. Fourth is quality control measures. Establish robust acceptance criteria for retention time, ion ratios, and peak shapes. Use isotopically labeled internal standard when possible. They experience the same matrix effect as your analytes. Implement regular system suitability testing before each analytical batch. Monitor control chart for IS response and ion ratios over time. Validate your method thoroughly, including matrix effect assessment. The last one is data review best practices. Never rely on automated integration alone for critical decision. Manually review chromatograms, especially for samples near decision limit. Compare peak shapes between standard and samples. Significant differences warrant investigation. Use consistent integration parameters across all samples in a batch. When in doubt, reanalyze the confirmation methods or alternative techniques. So to summarize, false negatives and false positives are preventable through careful method development, rigorous quality control, and thoughtful data review. The key takeaways are: understand your matrix effect, optimize chromatographic suppression, select specific MS-MS transition, implement comprehensive quality control, and always review your data critically. Remember, in analytical chemistry, the absence of evidence is not evidence of absence, and the presence of a peak is not always evidence of your target compound. Question your data, validate your methods, and maintain scientific rigor. I hope you liked the video, and if you have any question regarding this topic, please do drop it in the comment section. Thank you.